Question 7. A sphere of mass m attached to an inextensible string, as shown in the diagram, is released from rest at an angle theta with the vertical. When the sphere passes through the lowest point, show that the tension in the string is given by mg3 minus 2 cos theta in brackets. So what's going to happen is that this is going to swing down. It's going to be over there. This distance here would also be L, and we're wanting to find what the tension in that string is over that point. Now that tension is obviously going to have to overcome mg. So that's going to equal mg, but it will also have to provide a force to cause the centripetal acceleration. So it's also going to be plus mv squared over r, and that r is obviously going to be L. So what's important that I find is that I find what is my velocity. I'm going to need to find that. Now to do that, we can look at the potential energy at this point is equal to the kinetic energy at this point. If I call that point 1 and point 2, we can work with that, because what's going to happen is that at this point over here, there is a certain height above that, and that height is going to provide the potential energy. So the potential energy, the PE, is equal to mgh. Now I need to work out what that height is in terms of my other variables. So if I look at this section over here, now I'll draw this in green. If I look at that part over there, that forms a right angle triangle, and if I call that x, this is theta, I can say that the cos of theta is going to equal x over L, because in this diagram over here, x is my adjacent, L is my hypotenuse. So x is equal to L cos of theta. So I have that. Now, we are looking at h. H is going to equal L, the whole length from that point to this point, minus x. So h is equal to L minus L cos of theta. So I can put that into my potential energy. My potential energy is equal to mgh, so it's mg, but now I'm going to have L minus L cos of theta. And that's equal to my kinetic energy at this point over here, because all that potential energy would be changed into the kinetic energy, and that kinetic energy is equal to a half mv squared. So I can therefore say that my v squared, notice here that my m's will cancel, I can multiply by 3, so we're going to get 2g L minus L cos of theta is equal to v squared. So I'm going to get 2gl minus 2gl cos of theta is equal to v squared. Now I can put that into my tension here. My tension is equal to m v squared, which is this. So I can put that in. So I'm going to get 2gl minus, I'll put this all in brackets, 2gl cos of theta all over L plus, and let me just write this one, sorry, I'm just going to be writing over it, I'll do it in a different color, plus my mg. So if I just bring this down, bring this up a bit here. So notice that this is going to be 2 mgl minus 2 mgl cos of theta, all divided by L, plus mg. Now I've got an L here and an L there, those cancel. So I'm just going to be left with my 2mg plus an mg here. So that's 3mg minus 2mg cos of theta. And I can take out an mg, and I'm left with 3 minus 2 cos of theta. And that is what we were asked to prove.